In this video, we are going to explore the concept of density, understand the equation behind it, and finally see how we can experimentally determine the density of unknown solids and liquids. To begin with, density is simply a measure of how much mass a substance contains within a given volume. In other words, it tells us how tightly packed the matter is inside an object. To calculate it, we just need to divide the mass of the substance by its volume. Mathematically, this relationship is often represented using a formula triangle where the symbol for density is the Greek letter rho, which looks a bit like a lowercase p. Since mass is measured in kilograms and volume is measured in cubic meters in physics, the resulting unit for density is typically kilograms per cubic meter. For instance, let's consider solid aluminium, which has a density of 2,710 kilograms per cubic meter. That means if we had a solid block of aluminium measuring 1 cubic meter in volume, it would have a mass of 2,710 kilograms. Although kilograms per cubic meter is the standard unit in physics, density can also be measured in grams per cubic centimeter, a unit commonly used in other contexts. To convert between these units, remember that 1 gram per cubic centimeter is equal to 1,000 kilograms per cubic meter. So, aluminium's density could also be expressed as 2.71 grams per cubic centimeter. Let's apply this with an example problem. Suppose we are asked to calculate the volume of aluminium that has a mass of 420 kilograms, and we are told that the density is 2,710 kilograms per cubic meter. Using the formula triangle, we rearrange the equation to solve for volume, which means dividing mass by density. So, we take 420 divided by 2,710, which gives us a volume of approximately 0.155 cubic meters. Now let's shift our focus to how we would determine the density of solids and liquids through experiments. Starting with solids, we return to our equation and realize we first need to know both the mass and the volume of the object. Finding the mass is straightforward. We simply place the object on a digital balance and record the value. Measuring the volume depends on whether the object has a regular or irregular shape. For regular solids like cubes or cuboids, we can calculate volume by measuring the length, width, and height, and then multiplying them. For example, if a cuboid measures 4 cm by 3 cm by 2 cm, its volume would be 4 times 3 times 2, which equals 24 cubic centimeters. However, if the object is irregularly shaped, we need to use a different method involving a eureka can and a measuring cylinder. A eureka can has a spout that allows water to escape, and when it is filled up to the level of the spout, any additional object placed into the water will cause its own volume of water to be displaced. That displaced water flows out into the measuring cylinder, and the volume of water collected is exactly equal to the volume of the solid. After finding both mass and volume using either technique, we can simply divide the mass by the volume to find the density. Determining the density of a liquid is a little simpler. First, place an empty measuring cylinder on a balance and zero the scale so the mass of the cylinder is not counted. Then pour in a known amount of liquid, for example, 10 milliliters, which is equivalent to 10 cubic centimeters, and record the mass. Once you have both the mass and the volume of the liquid, divide the mass by the volume to find the density. In general, the larger the volume of liquid used in your measurement, the more accurate your result will be, because a larger volume reduces the effect of small errors in measurement. Additionally, you can take multiple readings to identify any anomalous results and calculate a mean value for better accuracy. And that's everything for this topic. Hopefully, you found it helpful, and we'll see you in the next video.